Hi there. I meant to record this one live and I forgot. I will blame the 90-degree temperatures because that sounds like a really good excuse. But typically I would start from scratch on these notes, so my apologies for those of you that are watching this and trying to catch up. But the target, LT3, is trying to describe and analyze the motion of an object when given a position time graph. All right. I'm going to leave this here just to cover up some of that other stuff, but this is our first time where we're really reviewing what exactly do we or do we not remember about graphs. So make sure we know the y is the vertical axis, the x is the horizontal. You always want to pay attention to your labels. So we've got time in seconds and we've got distance from home in meters. With this graph, the general story was that somebody was going towards their bus stop. So home is down here at coordinates 0, 0, and they are heading towards the bus stop, which is up here. All right. Now, a lot of this is just review. So to start out with, do we remember from middle school or whenever our coordinate format? So x comma y. So the x value and then the y value. So for example, home is 0, 0. Now remember, we pay attention to the labels. So x was time in seconds, and y is the distance in meters. For slope, okay, that's the hills, so to speak. Now, don't get confused. This has nothing to running uphill, nothing to do with running uphill, or nothing to do with running downhill. Okay, but the angles, if we want to say, of these lines, that's called the slope. To figure out the slope, you probably have heard a math teacher at some point talk about rise over run. We change it a little bit because it's high school now, so we get a little fancier. It's actually the change in y over the change in x. This little triangle is the Greek letter delta. That is not important. What is important is that when you see this triangle, you know that it means change in. Okay, so you know that it means the change in something. We'll use this for much of first try of the course and the second try of the course. So we've got to know what triangle means. Okay, just don't say triangle y, triangle x. Change in y over change in x. So it's the change in the up and down divided by the change in the left and right. Now in math class, the goal ultimately, oftentimes, is to look at a graph and just calculate the slope. It isn't so important what the slope means, it's just the skill of can you calculate the slope. You don't see anything on our target about I can calculate slopes. We have to be able to use the data of what does the slope represent. So we take it a little bit farther, and it represents the velocity. Okay, so we'll start to think about why here. Hopefully we understand that if you have a line that's going up, that is a positive slope. Okay, that's a positive slope. If you have a line that is angled down, that's a negative. It's not showing a negative number necessarily. You will get a negative slope, but that's not the important part. In this class, what's important is that it's showing a direction. So if this guy's, I think his name was Tom in the story that this graph came from, if Tom is going from home towards the bus stop, he would have a positive velocity. Okay, that doesn't necessarily even mean he's speeding up, but a positive velocity. The negative would mean he turned around for some reason. Because if we look at these coordinates, 50 seconds in, he's 100 meters from his house, and then 20 seconds later, so 70 seconds in, what the heck, he is now only 40 meters. He turned around for some reason. You can use your imagination. A dog chased him. He dropped his phone. Who knows what it was, but he had to go back a little bit, and then it looks like he panicked a bit, because you look at this slope over here compared to this one, it's steeper. So it's like, oh man, he backtracked and oh boy, I'm going to miss the bus. He boogied. Okay, a steep slope shows you that he's covering a large distance here. Okay, that's a big distance in a short amount of time. So he's probably running at that point. And once he gets here, there's no slope. He stays at the same position. He stays 160 meters from his house, so he's probably at the bus stop waiting. So he's probably walking to school. Oh man, I dropped something. Turns around for 60 meters, and then oh man, I'm going to be late for the bus, and he boogies, he runs up to the 160 meter mark, which is more than likely where the bus stop is, and there he waits. So if we wanted to actually figure out one of these just for an example, Let's look at this little equation is for this first coordinate beyond leaving home. So it's for the 5100, 50 seconds into his trip. His end position is 100 meters, and he started at 0. Okay, so it's like your final position subtracting the starting position. And so when we do that, 100 divided by 50 is 2 meters per second. So he was traveling 2 meters per second in that interval. So this positive and negative, remember, it just shows direction. That's not a greater than. I was just trying to have one of those little, I'm never good at drawing these things. Ooh, that wasn't bad for me. But anyways, shows direction. Now the one thing that I'm going to add to this in the next session in the notes, and I don't want to do 2 recordings because who knows how long it'll take me to remember that one, is that this part of this graph up here, right? That part of the graph is, we have to know what a horizontal line is. And I don't mean that to undermine any intelligence, but some people will flip around horizontal versus vertical. So horizontal is left and right. If you see a left and right line on a distance time graph, we know that that object is at rest. They are not changing their position. If we see a nice, pretty, a linear line, which I always think sounds funny, or a line, so this is just a positive slope, or a line this way, negative, those are showing constant speeds, or a constant velocity. So they're covering equal distance intervals in each amount of time. So it's like if you're driving down the road and you set your car on cruise control and you're going a steady 75 down the expressway. You're not speeding up, slowing down, you're on a straight road, you're not changing direction. You have constant velocity, so that's going to be no acceleration. Remember, an acceleration is a change in motion. Okay, so if you had some funky curve up going on up here, which you've seen in some activities, it's still technically a positive slope, but it's like somebody maybe pedaling their bike, and they're going faster and then slower, faster and then slower. All right, then you wouldn't see these nice pretty lines this way. All right, that is it.